So we've heard of staple crops, but there are also tropical staple trees. Even there are staple vegetables which are perennial. So when you think of trees, you think of them as perennial, living for many years. You don't have to replant them every year. And we discussed all the advantages of trees under the multistrata agroforestry and tree intercropping and so on. Here, the same thing is done in the context of the food products that come out of trees, and they are considered staple trees, and we are focusing on the tropics, but I'll show some other regions as well. The ranking of this by 2050 is at number 14 with 20.19 gigatons of reduced CO2 by 30 years, $120.1 billion in net cost with 627 billion in net savings. Here's an example of what is called an elephant tree. It's a Marula tree that ranges from woodlands of southern Africa to as far north as the Sahel. It has a white crown similar to oak trees, and it is in the same family as mango and cashew. Mango, cashew, marula, all the same family. It's a prolific source of food for giraffes, rhinoceros, and elephants, with the latter being dominant consumers. So elephants rely on these trees. Marula produces an exceptional and delicious fruit with inner nuts that are a rich source of protein and marula oil. Elephants eat the fruit and branches and will munch on the bark as well, which is why it is sometimes called the elephant tree. As harsh as their impact is on the tree, the elephants also spread the seeds everywhere in the dung to make up for the damage they do to the trees. While these coevolutions over many millennia obviously work because they serve each other very well. Here is just a nice image of some of the trees that are being shown. I took some material from a couple of papers and reports on perennial crop types. So even though it says here perennial crop, we are talking about trees as well as perennial crops. So staple crops, perennials whose edible products contain high proportions of carbohydrate, proteins, and fats. So you have nuts and olive and oil palm, avocado, perennial beans, mesquite, and so on. You have sugar crops grown mainly on their sugar content, like cane sugar and date. So date is a tree, whereas cane sugar is a perennial crop. You can chop it off close to the ground, it can grow again. It's a water guzzler, and it's being grown for sugar in many places where it shouldn't be because it's a good cash crop. Nonetheless, that's a separate issue. Perennial vegetables exist as well, non-staple fruit crops, so tropical orchard fruit that do not contain large amounts of carbohydrate, proteins, and fats, but are often culturally important and rich in micronutrients, like apples, peaches, and oranges. Who doesn't like good fruit, right? Beverage and spice medicinal plants, perennial grains, so you can think of several of those that I won't read through. Fodder crops, of course, pasture, which can be perennial, and industrial crops like fiber wood, chemical extracts like rubber, inedible oil, wax, gums, which are used for various products. You can do that by nutritional categories of perennial staple crops as well, like basic starch crops, which include bananas, chestnuts, plantains, breadfruits, air potatoes, starchy trunks, and so on. I just want to run through these because I think you've heard many of these. Comparable annual crops include cassava, sweet potato, taro, and yams. Okay, so there are perennial crops which are similar, and then there are tasty annual crops as well. Balanced carbohydrate crops, so they have protein and oil. Carbohydrates can be either starch or sugar. These crops include crops such as Mayan breadfruit, mesquite pods, Tahitian chestnut, and with comparable annual crops as well. protein crops, protein oil crops, and oil crops. So I won't go through all of them, but here the same paper also provides a table of soil organic carbon estimates for perennial crops in different climate regions. So we are not just talking about tropics, but going a bit beyond. So looking at tons per hectare of soil organic carbon, which is a critical ingredient that we've been talking about. We kept saying soil carbon, but obviously organic carbon is what we meant most of the time. But this is direct sequestration from plant photosynthetic and root activities, whereas the biochar and so on, we are pyrolyzing and putting back carbon that degrades slowly. Arid climate, you have under perennial agriculture 19.15. Boreal has higher. Tropical forests can have a very high forest density, very large production of organic carbon, but because of the temperatures, the respiration rates and degradation of soil carbon will also be very high. So you can see that a little bit here. So that's the Mediterranean and temperate climate. So there are the various numbers of soil organic carbon estimates in terms of tons per hectare. This is from this report, agroforestry.org, based on the paper by the author of this blog on this site. And here are the perennial carbohydrate crops with yields. I'll just read a few. So there are tropical, humid tropics, humid worldwide, to highlands, and so on and so forth. But you can see the name: cassava, yucca, banana, plantain, peach palm, potato, breadfruit, taro, Tahitian chestnut we mentioned, sago palm, air potato, date palm, lucuma, honey locust, jackfruit, which is incredibly sweety as well, carob, tropical mesquites. These are annual staple crops that I won't go through, but perennial protein crop yields. Why are they listed in perennial? Well, let me leave it there. So chachafruto, breadnut, runner bean. So that's the climates in which it will grow, and there are more: lima bean, pigeon bean, soybean, and so on, pistachio, peanuts, marula, common bean, and so on. Okay, these are high in protein. These are high protein perennial leaf crops, so chipilin, mulberry, moringa, soybean, chia, spinach. So in this case, perennial basically means you don't have to replant them every year. You can chop them off close to the ground and they can regrow. But you can check the details. Here are some edible perennial oil seeds just to close out the story. African palm is here, coconut palm, avocado, Brazil nut, macadamia, pecan, olives, rapeseed, poppy, sunflower, and hazelnut, and so on. Okay, so in summary, tropical staple crops currently grow on 116 million acres, mostly in the tropics. The rate of sequestration is high at 1.9 tons per acre per year. Expand this area by another 153 million acres by 2050, and they can sequester 20.2 gigatons of additional carbon dioxide. Our analysis assumes that expansion only occurs on existing cropland with no forest clearing. So that has to be made very clear, that you cannot trade forests for these perennial staple trees. That's not a zero-sum game. Because their yield is 2.4 times higher than annual staples, at 60% of the cost, the savings are significant, while cost to implement is low. Okay, so trees are always good, but if they can provide services like staple food items, obviously they are part of the solution, especially if they can also sequester additional carbon and bring net benefits in terms of savings, monetary savings. Okay, leave it there.